Okay, so in the last video we talked about what is probability, right? The value or likelihood that something is going to occur. It always ranges from 0 to 1. So let's go ahead and see if we can calculate some probabilities. Remember, there's two different kinds. One is experimental, one is theoretical. The theoretical probability here, number of times the event could occur over the total number of possible outcomes. So we're going to look at this given that our data is arranged in different ways. This example 1 is specifically arranged in a Venn diagram. So this says you reach into a box of 12 crayons and grab a crayon without looking. Again, it says without looking because we want it to be random. What is the probability of choosing A? And then we use this probability notation. So the probability you choose peach. If we look at our Venn diagram over here, you'll notice that there's one peach crayon within the box of crayons. So that would be one possible peach out of the total 12 possible crayons. So our probability would be 1/12. Or again, we can write this as a decimal. And if I do 1 divided by 12, I get 0.083. If you're going to write probability as a decimal, which is great because then you can compare it well to other ones, go out at least 3 decimal places. The reason being is if you're rounding too much here into the probability, it just changes really fast. Probabilities only range from 0 to 1. So any rounding within that can kind of change that probability a little drastically. Okay, probability that we choose color in the American flag for the second one. So if you look at your American flag circle, there's 3 of them within the American flag. So that would be 3 out of the total 12 colors would work for this one. Generally, we would simplify that down to 1/4 as our final answer. Or again, if we want to write it as a decimal, that would be 0.25. The next one, probability of getting a pink. If you look in here, there's not one specific crayon that is named pink, so there would be 0 out of the 12 that would result in getting a pink, or in other words, we would just call that 0. Probability of getting not a primary color. So if you look in here, this one's not, this one's not, this one's not, right? All of these are not primary colors. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9 of them, right, out of the 12. Again, we simplify, so that would end up being 3/4, or in other words, we could write it as 0.75. Okay, maybe try the next one and then continue the video and see if you can calculate these probabilities here on examples 2 and 3. Example 2, you're just given some information, no Venn diagram or table. It says you have a bag of Skittles. The bag contains 6 blue Skittles, 3 green, and 2 red. You reach into the bag and grab 1 Skittle. What's the probability you choose? So a blue Skittle. So how many blues were in there? We look up here. It looks like there were 6 blue Skittles. So 6 out of the total. And again, this one doesn't tell me a total, so I need to calculate that. So I've got 6 blue ones plus 3 green ones plus 2 red. So that's 9 plus 2. It looks like there's 11 Skittles total. So when we calculate this, we've got 6 over 11. And again, we could leave it as a fraction or write it as a decimal, 5, 4, 5. Again, going out at least 3 decimal places. A green Skittle, so if you look in there, there's 3 green Skittles out of the 11, so we can leave it as 3/11, or in other words, we can write it as a decimal of 0.273. And then the probability of getting a yellow Skittle. So if you look at this one, it doesn't look like there's any yellow even in the bag. So 0 out of 11 would be a probability of 0. Example 3, this one gives you a two-way table. So if we look at this one, this says the two-way table at the right displays the results of a survey of students regarding their chores and curfew. If one student is randomly chosen, calculate the following probabilities. So first, again, it's saying how many students were surveyed. We need to know the total so that we can calculate probabilities. So I'm going to fill in these column totals really quick. It looks like in my curfew column, a total of 25 students have to do curfew or have a curfew, and 8 of them don't. So if I add up the 25 plus the 8, I should get 33, it looks like. If I look at the rows, so looking at my people that do chores, 13 plus 5, it looks like 18 of them have to do chores, and 12 plus 3, 15 of them don't. And then again, we make sure that this adds up to that 33 as well. So both the row and the column should add up to that total. So total, there were 33 students surveyed, so we can calculate. What's the probability if a student is chosen that they have to do chores? So we look at our two-way table and we go to where it says chores, and they do have to do chores. So if you look at this row right here, it looks like 18 total have to do chores out of the 33. So we would write 18 out of the 33 have to do chores. And again, you can leave that as a fraction, or we could write it as a decimal, which would be 0.545. Okay. Probability they don't have a curfew. So we look over here, and again, curfew is the columns. So these ones do have a curfew, these ones don't. So we only need the ones that don't, and we're looking at 8 of them out of the total 33 students. Okay, so if we do 8 out of 33, we end up with 0.242. And then lastly, probability they have a curfew. So if we look at, there were 8 of them that didn't have a curfew, the other 25 do. So this would be 25 out of 33. And again, if I calculate that into a decimal, then I'm looking at about, it's a little squishy here, 7.5, and then it rounds, so it's about 7.58. Notice that these are essentially, they're like opposites. They're what we call complements of each other. So the probability they don't have a curfew, the probability they have a curfew, that accounts for all 33 students. Some of them have the curfew, some of them don't. But you'll notice that if you were to add these two up, they should give us 100% of the outcomes. That would account for all the possible things that could occur, right? Having the curfew and not having the curfew.